The objective of this activity is to find the prime numbers from 1 to 100 by this method called Eratosthenes-Sieves method. Let's understand the concept of prime numbers first. If you consider a number like 21, how many factors does 21 have? It is divisible by 1, of course. It is divisible by 3, divisible by 7, and divisible by 21. So how many factors are there? There are 4 factors. Any number which has more than 2 factors is known as a composite number. So 21 is a composite number because its factors are more than 2. Now consider another number like 17. 17 only goes into 1 and 17 itself. There is no other number which divides 17. And since it has only 2 factors, this number 17 is known as a prime number. So do you know how many prime numbers are there between 1 to 100? We can actually find these prime numbers or locate these prime numbers in a grid of 10 by 10, that is 1 to 10, 11 to 20, written up to 91 to 100 using this amazing activity. And let's see what material we require to perform this activity. We require a grid paper, as I told you, a 10 by 10 grid on which the numbers from 1 to 100 are indicated. Obviously, we need markers and the general material like tracing paper, etc. Let's perform this amazing activity now.
To perform this activity on prime numbers, as you can see here, we have cut out a square shaped piece of chart, and we have drawn a 10 by 10 grid on the piece of paper. Then we have written the numbers starting from 1 and up to 100, so we don't have to like miss out on any number, and ensure that you write all numbers from 1 to 100 in rows of 10 each. Now using this, you have to place it here on the table and then place a tracing paper on it like this, and you can see what happens. It exactly overlaps. We have to draw the matrix only without writing the numbers on it. So you can see here, if I place it like this exactly overlaps with this, but if I remove it, you will see that only the grid is drawn here. The numbers are not written on this. The numbers are only in the chart paper. Now we will place it again so that it overlaps like this, and now we will start striking out some of the numbers. The number 1 here is not a prime number. 1 is neither prime nor composite, so it's not a prime number, so we will cross 1. And next we will encircle 2 because 2 is a prime number, and we will cross out all the multiples of 2 in this entire grid. So the entire row here, column, and the row containing all the multiples of 2's will be crossed out. You can see I am crossing out all the even numbers, so they are not prime numbers, so they are all crossed out. And now I'll encircle 3 because 3 is a prime number, but multiples of 3 I have to cross them out. 6 is not there, 9 will be crossed out, 12 is not there, 15, 18 is crossed out, 21, then 24, 27, 30, 33, 36, 39, 42, 45, 48, 51, then we have 54, 57, 60, 63, 66, 69, 72, 75, 78, 81, 84, 87, 90, 93, 96 and 99. So I encircled 3 and I have cancelled all the multiples of 3 because they are not prime. Similarly, do it for 5. 5 is a prime number, so I don't need the multiples of 5. all the multiples of 5 ending in zeros, they have already been cancelled. So you have only this row. So this row is also cancelled now because they are multiples of 5 and they are not prime. Likewise, we can encircle 7 and cancel out the multiples of 7. 14 is already cancelled, 21 cancelled, 28 cancelled, 35, then 42, 49 I have cancelled now, 56, and then 63, then 70, 77, and then 84, and then 91, and then 98. So all of them have been cancelled. Now the positions of all other numbers, 11 is left out, 13 is left out, 17 is left out, 19, I am just encircling whichever numbers are left out, 23, 29, 31, and then we have 37, 41, 43, and then we have 47, and after that it is 53 and 59, then 61, and then 67, followed by 71, 73, 79, 83, and then 89. After that it is directly 97. So all the circled numbers, this gives us the set of prime numbers. So if you remove this sheet, the positions of the prime numbers will be indicated here. As you can see, we have obtained all the prime numbers and positions corresponding to these are all prime. So that completes our activity on prime numbers.